for today's science experiment, we are going to do a line time about magnets. So first, I'm going to read you this book, and then for our second video, we are going to do our experiment. Okay. So let's learn a little bit about magnets. Okay. It says, you draw a picture of your dog that you really are proud of. So proud that you decide to put it on your refrigerator so everyone in your family can see it. You use a magnet or two to keep the picture in place on the refrigerator door. But what is a magnet? And why does a magnet stick only to certain objects? Right? Picture of the dog. Here's a little fun fact. I'm going to read this little fun fact. Did you know that farmers sometimes put a magnet in a cow's stomach? Any metal that cow may eat sticks to the magnet, keeping the metal from hurting the cow. That's a very interesting fact. So here's the next page. Around every magnet is an invisible magnetic force field. Magnetism, I'll say that word again. Magnetism is a kind of force. It's this force that attracts iron objects to magnets. You can feel this pulling force when you hold a magnet near an iron object, such as a paperclip. Every magnet has a north pole and a south pole. The poles are at each end of the magnet. The magnet field is strongest at the poles and flows out of the North Pole and into the South Pole of a magnet. The arrows show the direction of the flow of the magnet field around the bar. So, this is your magnet right here. Okay, this is the South Pole and this is the North Pole, right? And the magnetism is strongest at this end and at this end. And when they come together, you could see the flow coming this way over that way. See? And then at this end, it's going this way, down this way. Can you see that? See? Coming out and in. Now, here's another fun fact. Did you know if you hit, drop, or heat a magnet, it may lose some of its magnetic power? That's pretty cool. If you experiment with two magnets, you'll notice that sometimes they attract each other, but other times they seem to push each other apart. When opposite poles, a south pole and a north pole, face each other, they attract each other. They like each other. When like poles, both south poles or both north poles face each other, they repel each other. That means to push away. So, here's a north pole and a south pole, and you will see that they attract each other, so they go together. When you have two north poles trying to come together, you can feel them pushing away from each other. You can feel that power pushing away. And also, when you have two south pole magnets trying to come together, you can feel them pushing away. Now, I have a question for you. What is the biggest magnet on Earth? Who knows? The biggest magnet on Earth is Earth. Our planet is made of different layers. We live on the outer layer, which is called the crust. That's right. Beneath the crust is a layer called the mantle, and at the center, called the core, is a giant ball of iron and metal nickel. This ball creates a magnetic field around the planet. So Earth is actually a giant magnet. So here you go. So we live right here on the crust. This right here is the mantle. And then here is the core. Like all magnets, Earth has a north magnetic pole and a south magnetic pole. These poles are located close to geographic locations we call the North Pole and the South Pole. So here's the North and here's the South. We use the directions north, south, east, and west to locate places on Earth. A compass tells us which way is north. Once we know where north is, we know which direction south, east, and west are. Inside of a compass is a magnetized needle. It lines itself up with Earth's magnetic field, and it points towards the North Magnetic Pole. People use compasses to find their way on land, in air, and in the sea. See? So north, south, east, and west. And we always know where west is, right? Because it goes towards the direction of the ocean. Here's another fun fact. Okay. Did you know scientists found about 30,000 years ago Earth's magnetic field flipped over? Back then, the North Magnetic Pole was where the South Magnetic Pole is now. It's like opposite day. Long ago, sailors didn't have compasses. They used the position of the sun, the stars, or land to find their location at sea. But sailors couldn't see the stars on stormy nights, and they couldn't see the sun or land at night, so they often got lost at sea. Then people discovered a special kind of stone called magnetite. This hard black rock is a natural magnet. Sailors noticed that if they hung by a string a long piece of magnetite, so I can't even speak, the stone pointed north and south. They call this stone a leading stone or lodestone. The lodestone was the first compass used by people. Now here's a science fun fact. Scientists think the fish salmon have magnite in them. This lets salmon use Earth's magnetic field to help find their way to the place where they were born. A magnet can magnetize objects it attracts. These newly magnetized objects will attract other magnet objects just like a regular magnet. But these magnets are only temporary. When they are removed from the magnetic field of a magnet, they lose their magnetism. Keepers, special iron bars, can be placed across the poles of a magnet to keep its magnetism longer. Other magnets are permanent. Once these objects are magnetized, they stay that way for a long time. Magnetite and the needle in a compass are two kinds of permanent magnets. So the rock and the compass. You can make a needle into a permanent magnet, but it stays magnetized for only a short time. To magnetize a needle, stroke the needle on a magnet several times in the same direction. To understand how the needle is magnetized, you need to look inside the needle. The tiny bits of iron inside the needle act like magnets, each with their own north and south poles. Before you start to stroke the magnet, these tiny magnets are pointing in all directions. If you stroke the needle toward the North Pole, the North Poles are tiny iron bits begin to turn toward the direction of the stroke. After 20 or so strokes, all the iron bits are lined up in the same direction and the needle is magnetized. So, that is a picture of a needle, right? And these are all the little parts inside the needle. And you see how they're all going in different directions? But once you stroke the needle, right? What did it say? 20 times in the same direction, then all the little bits start going in the same direction. You're around magnets or magnetic all the time, but electromagnets can be turned on and off. An electromagnet is made by wrapping a wire in a coil around an iron core. The wire doesn't need to be magnetic. It just needs to conduct or let pass electricity. The magnetic field lines bend around the wire. When electricity is passed through the wire, the electromagnet is magnetized or turned on. The more loops the wire has around the core, the greater the current of electricity, the stronger magnetic force of the electromagnet. See? Electric magnets are used in many of the electric machines we use every day. They run the motors that let refrigerators cool our food. They are used to separate metals in recycling bins. They help produce the electricity we use in our homes. And they run escalators, elevators, subways, and more. How many ways have you used magnets today? So here we go. Think about it. Let's see, our last fun fact. Did you know some people travel from place to place on maglev trains? These trains use electromagnetism to float above the track. How cool is that? I would love to see that. Okay, now I want you to go around your house and see what do you think is magnetic and what do you think is non-magnetic. Okay, and you can watch the next video that we're going to do, and we're going to make our own magnets out of rocks.